All right, so today we're going to take John Napier and we're going to put him into practice. And we're going to start playing around with logarithms. Because remember, John Napier invented logarithms so we could do math quickly. Aren't you excited? But back in your grandparents' day, they didn't even have calculators or tables like I had. They had a slide ruler. And if you talk to some of your grandparents, they may remember what a slide ruler is and even how to work one. But for our case, we've got our good old calculator, so we just have to understand the basics of what a log is. So let's just dive right into it. This is what you like. Nice, good math. Let's do something like 5 squared gets me 25. Oh, life is good. Well, John Napier came around and said, I can make that easier. Really, he did. So what you are charged with today is taking this problem over here and putting it into log form. So the base, when we talk about logarithms, is actually a sub. Notice it is below the word log. It's in the sub position. Sub means below, super means above. We are in the sub position. So 5 goes down here. Exponent goes here, and power goes there. And that's the hardest part for kids to understand. But this is how I read this logarithmic equation. What is the exponent? I don't say the word log. I substitute in the phrase, what is the exponent of base 5 that gets me 25? That's what this problem is saying. What is the exponent of base 5 that gets me 25? The answer is 2. Yay! So I'm actually going to take this phrase and I'm going to use it. All right, so let's try practicing taking things that are in log form and writing them good old-fashioned way. So for example, this is Napier. This is how he would deal with it with logs. But we don't want Napier. We want us. How can we do it? Because we got calculators now, so we don't need logarithms. All right, so we look at his problem, and we've got to pick out the base. Well, that's easy. The base is always in the bottom. But now we have to decide, is 6 the exponent or is 64 the exponent? Now in this problem right here, it makes sense. If you put 64 as the exponent, does 2 to the 64th power get you 6? No. 2 to the 6th gets us 64. Again, I say it as this. Instead of saying the word log, I say the phrase, what is the exponent of base 2 that gets me 64? 6. Okay, how about this one? What is the exponent of base A? Okay, so A is my base. That gets me 1 over A. All right, so that gets me 1 over A. So, yeah, my exponent has to be -1. All right, how about this one? What is the exponent of base 2? Okay, so there's my base of 2. That gets me x? Well, 4. Well, if I had to figure this out, if somebody said, hey, well, what is x? Well, then, look, I got a nice little problem to figure out. 2 to the 4th power, x is 16. Now, I didn't ask you to figure out what the answer was. I just asked you to rewrite each one of these. Now, I had a kid up in New Hampshire, and his name was Josh. And Josh didn't get logs at all. He never got them right. He never knew what to put where. So Josh, who was the son of a logger, invented something called roll the log. See, his dad was somebody who went out on the side of the hills in New Hampshire and cut down the trees. And how did you get a tree from the top of the hill to the bottom? Well, a lot of you guys watch that show Axeman now, and they actually roll it down the hill. They clear a pathway and it rolls down to the bottom of the hill. So he invented rolling the log. And when you roll a log, you always start with the base. And you roll it. And that's how Josh remembered it. 2 to the 6th power gets me 64. Roll the log. Start with A. A to the negative 1 gets me 1 over A. 2 to the 4th power gets me x. And actually, to this day, that's how I do it as a shortcut. Really simple. Okay, now we're backwards. Oh, no, we're not backwards. Not yet. Silly me. We still want to rewrite these in base form. So let's try Josh's little shortcut. 49 to the... Wait, there's nothing there. Okay, if there's nothing there, I'm going to designate nothing with the letter x. That's what we do in algebra. So this one would be 49 to the x power gets me 1/7. And if I wanted to solve this, I would have to say, 49 raised to what power gets me 1/7? Well, I know 49 raised to the 1/2 power gets me 7, because the square root of 49 is 7. So I guess if I had to solve this, x would be negative 1/2. Okay, let's try the next one. Oh, I like this one better. B to the 3rd power gets me 27. B to the 3rd power gets me 27. And if I had to solve that, well, I think I could figure it out. I could figure out that B is 3, because 3 to the 3rd power would get me 27. But I'm not worried about that right now. I'm just worried about rewriting. God, this Josh shortcut really makes this easy. B to the 1/4 power gets me 5. So the base is B. The exponent is 1/4, and my answer is 5. And again, if I had to solve that, the 4th root of what number gets me 5? Well, B would be 625. But we're not worried about solving them right now. We're just worried about rewriting them. One more. Love that Josh shortcut. 16 to the... Hey, nothing's there. Right, if nothing's there, I just hold it with an X. So, without my little template, 16 to what power gets me 64? And if I had to solve this, let's just go back to chapter 7. And this is why chapter 7 came before chapter 8. I'd have to rewrite these in like bases. So 16 is 4 squared x. And 64 is 4 to the 3rd. So now that I have common bases, I can ignore them. And 2x equals 3. So x equals 3/2. Okay. Done.